So in this lesson, we'll be learning how to calculate the distance on a curve. So sometimes, well, let me demonstrate this by using a exponential function. As you can see, you might have an exponential function going like this with the vertical asymptote. Here, as the demonstration shows, the horizontal asymptote will be y equals to 0. As you can see, sometimes you'll be told to find the distance between 2 points on the curve, not the average distance where you take a shortcut, but the distance of an arc on a curve. So now let's look at the first question of today. So here you are given this function, and then the formula that you have to use is the one on the calculus, where you are told to integrate between 2 points shown by the x-axis. So as you can see, the formula that we'll be using will be the arc will be given by this thing here to be the square root of 1 plus the derivative, plus the derivative of the given function, which will be dy over dx, and then you're gonna square that. And don't forget about this because you're integrating. So as you can see, this is the final point, this is the initial point. So looking at the first question, I believe that we have to write this in terms of y. Firstly, let's solve for y in that case. So it's gonna be y square equals to 4x to the third over 9. Now to find the value of y, you're gonna square both sides. So it's gonna be y equals to the square root of 4x to the third over 9. So do not involve the negative sign here, but only the positive sign. So simplifying this, you're gonna get 2 over 3 x to the power of 3 over 2. Now let's substitute the value on the equation that we going to use. Now the thing that you can do is just to say here the b represent 3 in this case, and the a represent 1.5, and then you're gonna have the square root of 1 plus the derivative of this thing. So as you can see, the derivative of that thing would be given by 3 over 2, this 3 over 2 over here, multiplied by the whole thing, which is 2 over 3 multiplied by x to the power of 3 over 2 minus 1, and the answer will be x to the power of 1 over 2, or the square root of x. So let's just write x to the power of 1 over 2, and then don't forget about that square over there. Now let's try to simplify this. It's gonna be 3 over here, 1.5, square root of 1 plus x dx. Now let's integrate this function over here. So you know that if we represented it like that, it's gonna be the same as 1 plus x all to the power of 1 over 2 dx. Now looking at this function over here, we're going to say this plus 1, it's gonna give me 3, it's gonna be 3 over 2, but here we're gonna write the multiplicative inverse of that as 2 over 3 multiplied by 1 plus x. It doesn't affect you a lot because the exponent of x in this case is 1, so it is simple in that case. So remember that we are integrating that function over there. Here it's going to be 3 over 2. Now we are arranging this from 1.5 to 3. Now you're going to calculate what you have. So it's gonna be 2 over 3 multiplied by 1 plus the x value start by 3. It's gonna be 3 over 2 minus here. It's gonna be 2 over 3 multiplied by 1 plus 3, or not 3 over here. Here you're going to say 1.5, and then it's gonna be 3 over 2. Now you can use the calculator. Now the answer will be 2.7 units. Now let's do the second question. For the second question, we did the same thing we did on the first question. So let's first find the derivative of the function that we are given. So it's gonna be dy over dx equals to, remember that during your lessons of finding the derivative of a function, looking at the natural log of a function, when you say derivative of a function which is ln u, you were to say the integral, the derivative of u over u, just like that. Even here you do the same thing. So firstly, you know that the derivative of cos x equals to negative sine x, and then here u is represented by cos of x. Now you remember that the formula to find the distance between 2 points on the curve is, it says s equals to the integral ranging from a to b of 1 plus the derivative of a function that we are given, which is this one, dy over dx all square. Don't forget this because you are integrating. So now we do the substitution in this case. So it's gonna be, our b would be, let me say s equals to, the b equals to pi over 4, and a equals to 1 over 2 or 0.5. And it's gonna be the square root of 1 plus the derivative of a function is this one over here. Now it's gonna say negative sine x over cos x all square dx over there. Now let's look at the thing that we can do first. Let's integrate everything over here, or firstly let's just simplify whatever we have over there. It's gonna say equals to pi over 4 over there is 1 over 2, the square root of 1 plus here the whole thing should give you tan square x, because this, you know, that is a quotient identity, and then there you're gonna have dx. Now before you can integrate this thing over here, you have to simplify it first, and then on the identity you know that 1 plus tan square of u equals to secant u square, just like that. Now for that thing it's gonna be the square root of secant of x square over there. So this and this will cancel each other, so I don't have to write anything over here. I'm just gonna say secant of x dx over there. Now the main thing that we should look at now is to integrate this thing. You know, or you should multiply this by the value of 1, which is that thing that says secant x plus tan x over secant x plus tan x. So you can see it's the same thing, which can turn this into y. So you are going to say, or let me just write everything quickly so you don't have to lose space for some other cases. Now you can say secant of x plus tan x over secant x plus tan x dx over there, and then you can say this function here at the bottom is equals to u. You can substitute it by u to simplify some things. So you can say u equals to sec x plus tan x. Now you have to derivate this, so it's gonna be du over dx equals to, this will give you tan x multiplied by sec u plus sec square x. So as you can see, this is equivalent to this over here, so you can replace some things with what you know. So here don't forget to get rid of dx on this side, So it's gonna multiply everything in this side. So it's gonna say dx on this side. So you can evolve even this dx. So the last thing that you can say is this whole thing at the top is equals to du. So on the bottom you can say u. So don't forget that you are integrating pi over 4, 1 over 2. So you remember that during the lessons of integration, I mean derivations, derivating the natural log function, you were to say ln x, the derivative of ln x equals to 1 over x. Same thing we're gonna do on this part over here. So it's gonna be so don't forget you reverse it to this part over here. It's gonna be ln u and then don't forget about these things. So you know it ranges from 1 over 2 to pi over 4. So don't forget about this u, that it is equals to this thing over here. So you can say, or let me find a little bit of space to write the full answer. So you remember that you have that thing, or the arc equals to ln of, or natural log of sec x plus tan x. And then you know it ranges from pi over 4, I mean to pi over 4, from pi, I mean 1 over 2. Now you do the substitution. So it's gonna be ln, a natural log of sec pi over 4. Now after you substituted everything, you have to put this thing on the calculator, and don't forget to put your calculator on the radian form. So the answer here is gonna be 0.36 units. So that's how you do that question.